Hey gang, STAT1800. I'm going to attempt to keep these videos at about 20 minutes. There's some research out there that shows the instructional videos in online classes are more effective if they're kept around 20 minutes. I don't know if it's true or not, but I'm going to assume it's true. I'm going to try it. Anyway, STAT1800 second video. What are we doing here? We're doing confidence intervals. The purpose of confidence intervals is really kind of twofold. We can either estimate an unknown value in a population, or we can test a claim about a value in a population. All right. Previous video we saw that if we're looking at the percentage between two values in a normal distribution, in the Z distribution, that the bounds on the middle 90% are negative 1.645 and positive 1.645. The bounds on the middle 95% are negative 1.96 and positive 1.96, and we see the bounds for the middle 99%. Now, let's switch gears and set the foundation for establishing a confidence interval. Now again, let's focus on this part right now, that we want to estimate an unknown value in a population. Now, we come down to what I've set up here. So we're going to estimate mu. Mu is unknown. Let's say we want to know the average IQ of all nurses in the state of Ohio. Does anyone know that? Well, I don't, so it's clearly unknown. But I know that the population standard deviation of all IQs is equal to 15. But I don't know the mean of the specific population that I'm targeting here, nurses in Ohio. Well, if I wanted to do that, what I would do is I would go out and take a sample of size n. I would want my n to be relatively large, 30, 25, 30 or higher. 100 always works nicely. Maybe two, whatever. I want some sample size set. And I want to estimate with 95% confidence this unknown value of mu. Again, the average IQ for nurses in the state of Ohio. Well, what I would do is I would go back to the central limit theorem and I would say, okay, what do I know? I know if I went out, even though I'm not going to do this, if I went out and took all possible sample means of size n from the IQ of nurses in the state of Ohio, that I would get a distribution of sample means X bar. These things would be centered, this distribution of sample means would be centered at mu. Now guys, you got to shift your way of thinking here. Mu is unknown. And I can't go out and just take sample, well I could, but it'd take forever. That's not what we do in statistics. But if I could do this, take the distribution of sample means. This is the underlying probability distribution that would be created. It would be centered at mu, and it would have a standard deviation of sigma over the square root of n. More specifically, I know that 95% of these sample means would fall between two values. Now, what value would they be? They would be the mean minus 1.96. Now, why 1.96? Because of this over here. It's upside down, but you know what I'm talking about. Mean minus 1.96 times the standard deviation. And this upper bound would be mu plus 1.96 times the standard deviation. So 95% of these sample means, now guys remember, these are comprised of sample means in here. 95% of these sample means would be between these two values. Now, we don't do that. We don't go take all the sample means. We come in and we choose one. And just as an illustration, let's say that is the mean that I chose at random. I went out and I got in, and just for the sake of talking it through, let's say I went out and I got 35 nurses in the state of Ohio. I gave them all an IQ test, and their mean turned out to be something, whatever. And it was located right there. Now again, we don't know this underlying probability distribution. So right there is irrelevant because we don't know right there where it is, right? If this stuff could be any confusing, we don't know what this looks like. But in theory, we know what it looks like. So let's just say I got that one right there. Now, what do I know? I know that if I shift this interval over to be centered, so let's do that again. Shift it to where it's centered around the x bar instead of the mu, that this unknown value would be in there. What if this is the mean I got? Well, let's try it out. I've got this width. If I move it to be centered around this one, I'm going to make this one kind of... It would also contain, this interval would also contain the value I'm looking for. I'm trying to estimate. Well, if I got something out here, because I can get any of these, right? It's more likely I'm going to get something in here. But I could have a bad day, if you will, and get something that's kind of rare. What happens if I build this interval around that value of mu? Well, it's not going to contain the true population mean, is it? It's going to be outside the bounds. So guys, if we estimate what, let's just focus back in on this very first illustration. What does this interval look like? Well, again, we're essentially taking this and we're just moving it to where instead of centered around mu, it's centered around x bar. So this left bound wouldn't be centered at mu, it'd be centered around x bar, minus 1.96, sigma over the square root of n. What would the right bound look like? It's not centered at mu, it's centered at x bar, plus 1.96 sigma over the square root of n. So this interval that's centered at just this random choice, there's nothing holy about this thing, I just came in because I wanted to go there for no reason other than just an illustration. If I get a sample mean that's between negative 1.96 standard errors and positive 1.96 standard errors around the unknown population mean, then when I build an interval around it, it's going to contain in the interval the value of mu that I'm trying to estimate. But if I get a sample mean outside in this tail here or down here in this tail, then that interval isn't going to be built, it's going to be built around the sample mean, but it's not going to contain the value of mu that I'm actually looking for. So guys, what we just did is we just created a confidence interval. And because I focused totally on the 95% confidence interval, I created a formula for the confidence interval. So if I take the left bound, the right bound, I can create a 95% confidence interval formula, right? Essentially what I'm doing is I'm taking the sample mean, I'm adding and subtracting the 1.96 times the standard deviation over the square root of n. But what if I don't want What if I want 90% or 95%? It's kind of setting you up over here, right? Percentage between, guys, is really just the confidence interval level. The three most commonly reported confidence interval levels are 90% confidence, 95% confidence, and 99% confidence. These bounds, as I called them previously, are nothing more than your z-critical values corresponding to a particular confidence level. So if I want a 95%, I use plus or minus 1.96. If I want 90% confidence, I use 1.645 plus or minus. Same thing for 99%. Guys, these things are referred to, at least I refer to them as Z star. So generalizing this formula, we take X bar plus or minus our Z star, depending on what confidence level we want, over sigma, or times sigma over the square root of n. Isn't that thing just a dandy? Okay, that's kind of a complicated formula for a lot of people, but luckily for us, if we want a confidence interval, let me back up. I'm going to calculate one of these by hand, but I'm going to show you also on Statcrunch how we do these things very, very, very easily. So let's jump into a formula, or into an example. We'd like to estimate mu, the mean IQ for all nurses in Ohio. We know from previous studies that the standard deviation for all IQs is equal to 15. What do? I take a sample. What do? I get practical. IQ tests take a long time. Now you see all these goofy things on Facebook, and I saw something on Facebook or Twitter the other day that there was a validated IQ test. All you had to do was take 8 questions and you could find out your IQ. No, you can't. IQ tests take quite a while, and they're quite sophisticated, and they take a while too, as I just said. So I'm going to take a sample, and I'm not going to take many nurses because these things are costly and time consuming. So I'm just going to get 10 nurses chosen at random. I take this sample and I found out that these nurses have a sample mean of 112.42. Now, a lot of places, a lot of media especially, will treat these 10 nurses as if they're just perfectly representative of all nurses in Ohio, and they say, well, done deal. The mean IQ for nurses in Ohio is equal to 112.42. No, it's not. It's still unknown. This is just the mean IQ for these 10 nurses. And I'm using this to estimate the mean for all nurses. Guys, samples vary. If I went out 2 seconds later and got another sample of 10 different nurses chosen at random in the state of Ohio, they would have a different sample mean IQ. But this is the one I'm going to use because that's the way we do confidence intervals. We take one sample and we use it to estimate the unknown value. Now I'm going to plug this into my formula. So I know again my formula is X bar plus or minus my Z critical over sigma, or times sigma divided by the square root of n. So in this illustration, my mean is 112.42. Now it comes to my Z critical. How confident do I want to be in the calculation of my confidence interval? Well, guys, the status quo, the standard is usually 95%. So that's what I'm going to use here. I'm going to use 95%. So I'm going to estimate at 95% confidence the mean IQ for all nurses in Ohio. So what am I going to put for Z star? 1.96. Sigma, the standard deviation for all IQs, is 15. And my sample size is 10, so I do the square root of 10. Now, I'm going to put this information in my calculator. If you don't have a fancy smancy calculator, don't worry about it. I'll teach you how to do this on Statcrunch in just a second. So I have 112.42 minus 1.96 times 15 divided by the square root of 10. So my left bound is 103.12. And my right bound is going to be very easy to find. All I have to do is just change that negative to a positive, so I can just go second function entry and scroll over and change that negative to a positive. So 121.72. So I'm 95% confident that this interval contains mu, which is the mean IQ for all nurses in Ohio. Alright, what if I didn't have my handy dandy calculator to do that? 103.12, 121.72. Does Statcrunch do this? Yep, it sure does. So let's go to Statcrunch. Let's go to Stat. Let's go to our calculator. Let's go to... no, I'm sorry. We go to ZStat. And we'll go to one sample. And guys, I have the summary statistics here because I have the standard deviation. I mean, I don't have all 10 IQ scores. If I did, I would have the data and I would choose that. I just have the summary of the 10 scores. Okay, so I go to a summary. The sample mean was 112.42. The standard deviation was 15. And our sample size was 10. Now we'll eventually get into hypothesis testing, but for right now we're doing confidence intervals, so we choose confidence intervals from mu. And the level we wanted was 0.95. Alright, hit compute, and you'll see that you get a table with a lot of information, but the information we want for the most part is the left limit. Well, they call it the lower limit and the upper limit, or the left side and the right side, these two end. Let's go through the table and make sure we understand everything. This is a confidence interval for mu, which is unknown. Right here our sample size was equal to 10. Now, sample mean was 112.42. Standard error was 4.743. Now guys, how did they get that? Well, if you go back over to this, they get their standard error by taking 15 divided by the square root of 10. So 4.74 is the value that they're giving right there. Okay? The left limit is 103.12. The upper limit is 121.72 as we calculated by hand. So guys, there's really no need to calculate things by hand. I just did that as an illustration to try to get you to understand a little bit more about where these confidence intervals come from, how the formula driving the results that we get through Statcrunch. Now, let's say, for example, we would like to change things up a little bit. Even though 95% confidence interval is the standard, let's say we wanted to do a 99% confidence interval for some reason. And you see these reported in research sometimes, but most of the time you're going to see 95%. Well, guys, again, the calculation is going to be the same. The only thing that will vary from the 99% confidence interval will be the z-star. Our mean is still 112 point something, guys. I made all this stuff up as I went along, so I need to go back and try to figure this out. 112.42, okay? So the sample mean is still 112.42. But the z-star that corresponds to the 99% is 2.576. Standard deviation is still 15 over the square root of 10. Now, we probably got some of this stuff in our calculator. I'm going to go back and get that. So the only thing I need to change is 1.96 to 2.57. I'll insert a 6 there. So the left bound is 100.20. And the right bound is 124.64. All right. Do we always have to use the formula? Nope. Stat, z-stat, one sample with summary. Sample mean is 112.42. Standard deviation was 15. Sample size was 10. The only thing we need to do is change this to 0.99. Hit compute, and you see we focus on the last two values. So 100.20, 124.64. So guys, when you're doing your homework assignment, if you just like to be brutal on yourself, use the confidence interval formula. Otherwise, just get the calculate the confidence interval using Statcrunch. All right. Now let's go back. There's one more thing I want to point out to you here, and then we'll end this video, and then we'll get into the other video. And so guys, don't tone out on me just yet. Okay, the formula that we have in general form is this. Now, all of these parts have a name. It's important that we're able to communicate those parts accurately. Okay, so first of all, let's just talk about things to the left of the plus and minus and things to the right. If we look at the left of the plus and minus, what we have here is a sample mean, but in more general terms, this is called the point estimate. Now, everything to the right of the plus or minus is referred to as the margin of error. Now, the margin of error is the z critical value times the standard error. As a student one time said, Dr. Darber, how in the world am I supposed to know that? You're not supposed to know that. The expectation of you walking into the class was not you knowing any of this stuff. The expectation of the class is that you're going to watch the videos and give me an opportunity to teach you. So you're not supposed to know this stuff. But again, this stuff over here, that's called the point estimate. This is called your z critical. This is called your standard error. And the z critical times the standard error is called your margin of error. Now, if we want to know the margin of error, we can multiply z critical times the standard error, but there's an easier way to calculate the margin of error that I want you guys to get comfortable with. The easiest way to calculate the margin of error is to take the upper limit minus the lower limit divided by 2. So the confidence interval that we just found its margin of error, and I'm just going to use that for ME, all right? The upper limit, 124.64. Minus the lower limit over 2. Now guys, the only goofy thing you can do in your calculator to mess this up is not put the numerator, or do some sort of silly typo, but guys, make sure you put the numerator in parentheses because of order of operations. If you don't, it's just going to take the 100.2 divided by 2 and then subtract that from 124.64. We don't want that. We want 124.64 minus the 100.20. We want that done first and then divided by 2. So make sure you put the value, the numerator in parentheses. All right. So our margin of error here would be plus or minus 12.22. All right, gang. Seems like to me it'd be a great time for a sneaky quiz. I don't know, number something. I'm not really sure what sneaky quiz this is. Send to shawnee.edu. In the subject line, put sneaky quiz. STAT1800. All right. In the body, the only thing you have to do is tell me the margin of error for the 95% confidence interval. Now guys, I just calculated the margin of error for you for the 99% confidence interval, but earlier in the video, we created the 95% confidence interval. All you got to do is send me the margin of error for the 95% confidence interval, and you're going to get the easiest 25 out of 25 points ever known to man. All right? Guys, that's all I got. Take care.